Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Hakim. Will be presenting my laboratory video presentation, which is from class of AS2222B, and my experiment is experiment 1, which is simple pendulum. Okay, firstly for the theory, a simple pendulum may be described as ideally as a point mass suspended by a massless string from some point which is allowed to swing back and forth in a place. So, a simple pendulum can be approximated by a small metal sphere which has a small radius but a large mass when compared relatively to the length and mass of the light string from which is suspended. uh, if a pendulum is set in motion so that it swing back and forth, its motion will be periodic. So the time that it takes to make one complete oscillation is defined as the period, which is t. So another useful quantity used to describe the periodic motion is the frequency oscillation. When a simple pendulum is displaced when its equilibrium position, there will be a restoring force that moves the pendulum back towards its equilibrium position. As the motion of the pendulum carries it past the equilibrium position, so the restoring force change its direction so that it is still directed toward the equilibrium position. If the restoring force, which is can say is F, is opposite and directly proportional to the displacement of X from the equilibrium position, so that is satisfied the relationship. Okay, now we're gonna go to the objective, which is our mission is to determine the acceleration due to gravity, which is g, by means of simple pendulum. So then, we're gonna see the procedures of this experiment. First of all, a small metal annulus was suspended by a thin thread from a support, which allowed the length to be varied. And the second one, the length of pendulum was adjusted by drawing the cotton through the cork, and the length was set from 0.1 meter to 0.8 meter with 8 reading points. The third one, the free end was secured on the clamp and the pendulum given a small displacement. After that, the time of 20 complete swings was taken with the periodic time, which is t, observed. The fifth step, the data in the table was recorded similar with table 1. And next, step 1, 2, 3, and 4 was repeated again. And the seventh step, which is t squared value, was calculated and completed in the table 1. And the last step, which is a graph of t squared versus length, which is L, was plotted. We move to the result and data. Now we're going to see the data. The t, which is the periodic value we gain from the formula of t squared, which is t equal to 2 pi square root of L over G. So after we get the t value, the t squared value was also gained from it. And we're going to see after this the analysis of this experiment, which is we can see there are 5 main things that will be explained. First of all, we're gonna find a centroid of x and centroid of y. Centroid of x was gained by the addition of all of 8 points of x axis, which is 0.1 until 0.8, and divided by 8, so we can get 0.5. The centroid y was gained by adding all the points of y-axis and divided by 8, and we get the value is 1.809. Okay, the second one, we want to find the gradient, which is with the formula of y2 minus y1 divided by x2 minus x1, which is we get the value of the gradient is 4. Basically, in the graph, the gradient is representing the t squared value, so it is useful to be gained for the next step, because we can use it for the next step, for step 3, which is we want to find the g experiment. So from it, G experiment, we will use the formula of T equal to 2 pi square root of L over G. So we process the formula until we get the formula of G experiment equals to 4 pi square L and divided by T squared. So the value we get is 9.87 meter per second square. Okay, so this value will be useful for the next step, which is we want to find the percentage of error. The percentage of error is basically from the formula of G experiment minus G standard divided by G standard multiplied to 100%. So from we gain just now, the G experiment is 9.87 minus to 9.8. We divide it by 9.8 and then multiply to 100%. We get 0.7% of percentage error. So for the last step, which is step 5, we want to find the uncertainty, which is delta G. So you need to know the maximum and minimum value, which is maximum value we can get from the point of 3.7 minus to 2.86 divided by 0.6 minus to 0.7, and we get 4.2. And the minimum value, which the same step, 0.73 minus to 0.06 divided by 0.2 minus to 0, so we get the value of minimum is 3.35. So with the 2 points, important points we can get the uncertainty, which is delta G, from the formula of uncertainty is equal to the maximum minus to the minimum points, and we get the 4.2, which is the maximum point, minus the 3.35, so we get the uncertainty value is 0.85. So thus G, which is delta G, equals to 4 plus minus 0.85 with the percentage error of 0.7%. So that's all from me. This is my reference for settling this experiment video presentation, and thank you very much. I hope my presentation will fulfill all the rubrics needed from this code of course. Thank you from me. Assalamualaikum.